and show the addition reaction of how to do it. So this molecule has 1, 2, 3, 4, 5, 6, 7, 8 carbons. So this is a cyclohexane at least, but it has a double bond right here. So it is a cyclohexene. And this is an ethyl group, which is off the main chain. So this is a 1-ethyl cyclohexene. Here is the hexene, where the reaction is going to happen. In this addition reaction, we're going to use hydrogen bromine. This has two chocolate chips on it, which means that it's hydrogen. And this has 7 blueberries on it, which means that it's bromine. Bromine is going to attack, well, not attack, but go here. This bond is going to then be pushed out, and bromine go here. Now, hydrogen is going to take the less substituted area and it's going to hit right here, and it's going to create a bond right there. But of course, in a usual, when you're writing it out, you're not going to see that hydrogen. So you're just going to see bromine here at the more substituted position.
Okay, so with this mechanism, we're going to be showing an elimination, and there's 2 different types of elimination that we're going to be looking at here. We're going to be looking at a Zayshev product versus a Hoffman product. So I will be showing a Hoffman. So the first thing that always occurs whenever you have an elimination mechanism is the leaving group leaving. So this Br molecule is actually going to be leaving because it's a good leaving group. So now we are left with our 1-ethyl cyclohex-1-ene, and we have to look at the beta positions. So with this particular molecule, there are 3 different beta positions for our hydrogens. There are 2 hydrogens here on this ethyl, there are 2 on this part of the cycloalkane, and then there are 2 on this part of the cycloalkane. Now, depending on which elimination you're doing for a Zayshev or a Hoffman product, will depend on which hydrogen you remove. So today, I'm bringing my great little friend, terbutoxide, and it's going to be attacking one of these positions. To get a because it's more bulky, we're going to be getting a Hoffman product. And to get a Hoffman product, you're going to attack either this one here or this one here. And so I'm going to show that now. So it's going to take this hydrogen, and there's going to be a plus here. So now we're going to have a double bond right here like that to compensate for that plus and for the plus where the bromine has left. And there you go. That's your Hoffman product for this elimination mechanism.
We had terbutoxide, but instead we're going to have NaOH for this example. So NaOH comes in and takes out our Br because it's a good leaving group, and then it comes and forms a Zayshev product instead, and then one of the hydrogens gets removed by me.
Hi guys, so we are going to be doing a substitution reaction, and this is going to be SN2. Now remember, in an SN2 reaction, you're going to have a loss of a leaving group and a nucleophilic attack occur simultaneously. So, in the beginning of a reaction, we have an ethyl group with a bromine attached, and it's always essential to remember the lone pairs of electron on bromine. So, this is going to be our leaving group, and water is going to be our nucleophile. The nucleophile water is going to attack at the same region where bromine is. So with this arrow, we're going to show that water is going to attack right here in this region. Bromine is going to leave, so we'll use this arrow to represent that bromine is leaving. We're going to move our leaving group over here. Now we have water is going to be attached to where the bromine originally was, to this ethyl group. And it's essential to remember also the lone pairs of electrons and a positive charge on the water. Now this next step is going to be a proton transfer. In the proton transfer, we have yet another water, which is part of the reagent in the reaction, which is going to, from its electrons, attack this hydrogen, and then this bond is going to be removed from the hydrogen and this oxygen, and we're going to be left with hydroxide. So with these arrows, we're going to represent from these electrons, hydrogen is going to lose this bond with the oxygen. And now, on the ethyl group, we're going to be left with the hydroxide. And that is how you do an SN2 reaction. Thanks, guys.